Alright, virtual learners, I am going to show you how you can compare fractions today using a benchmark of 1/2. This is a strategy that we use so that we don't have to memorize any kind of tricks. We can use our reasoning, and it helps us develop that fraction sense. So in third, we're comparing fractions to half with models. We can use this strategy in third grade as long as there's models present. And then in fourth grade in Virginia, where I'm a math coach, we do it with and without models. So eventually students are going to have to be able to reason through problems like this, comparing these fractions without any models present in fourth grade. So we do start working on this in third. So the first thing that you have to understand in order to use this strategy of comparing fractions using the benchmark of 1/2 is students need to understand that 1/2 is not just one piece out of two pieces, but there are many equivalent fractions for 1/2. So the first thing that we do is, and a lot of times even before our fraction unit actually begins, we start exploring how many ways can we make 1/2. So we know that if this is one whole, these are fraction bars here. If this is one whole, 1/2 would be 1 out of 2 parts, which is just 1/2. So now as I'm looking down, I'm looking for pieces that are the same size as the half, because now I could see this is 1/2, right? So I'm looking at thirds. There's not any exact equivalent for thirds, but when I look at fourths, I notice that 2/4 are equivalent to a half. So I'm going to actually show that here. So 2/4, okay. Now let me see if I can make exactly 1/2 with fifths. I can't make exactly 1/2 with fifths. I'm going to keep that down a little bit. I wonder about, what are these? 1, 2, 3, 4, 5, 6. Sixths. Can I make half with sixths? I think I might be able to. What number is half of 6? Well, that's 3. 3 is half of 6. So 3/6 is equal to, or equivalent to, 1/2. Check it out. 1/2 is the same as 2/4. 1/2 is also the same as 3/6. Cool, cool. All right, let's keep on working. Okay, so half of 8 is 4. So 4/8 must be equivalent to 1/2. Let's see. 1/8, 2/8, 3/8, 4/8. And look, that's the same amount as 1/2. So those fractions are equivalent. All right, so I did 1/2 is the same as 2/4, is the same as 3/6, is the same as 4/8, and these were tenths, right? 10 is an even number. What's half of 10? Well, 5. I wonder if 5/10 is equivalent to half. It looks like it might be. It is. Cool. 5/10 is also the same as 1/2. So all these fractions mean the same thing. Make sure it's equal to 1 whole. Yeah, there's 12 parts. So 12, that's an even number, right? What's half of 12? 6. Ooh, I think 6/12 might be also equivalent to 1/2. That would be 6 1/12 or 6/12. These are all equivalent to 1/2. So as you're exploring this with students, you want to notice those things. Like if they don't start noticing it on their own, and a lot of times they will, you can ask them, you know, what do you notice? Now that we found all these ways to make 1/2, what do you notice? And a lot of times kids will notice the most important stuff. All these denominators are even, so we could easily half them. And when I write these fractions for equivalence, 1/2 is the same as 2/4. It's also the same as 1, 2, 3/6. It's the same as 4/8. The same as 1, 2, 3, 4, 5, 5/10. And that's also the same as 6/12. Now that I've written all these equivalencies out like this, all these ways you can make 1/2, what do you notice now? I notice that if I have half the number of pieces I need to make the whole, that's going to make half. 2 is half of 4, so 2/4 is half of 4/4, or 1 whole. 3/6 would be half of 6/6, which is 1 whole. 4/8 would be half of 8/8, which is 1 whole. So if your numerator is half of your denominator, you have a fraction that's equivalent to 1/2. Okay, so we do want to talk about these fractions that have odd denominators, because students will be wondering, can you do half with thirds? And in reality, you can do half with thirds, because if I cut this third in half to be equivalent to a half, can you see I have like 1/3 and then half of another third? So I could write that like 1 1/2. In 4th grade, I could write 1 1/2 thirds. Yeah, that's the same as a half, right? Let's look at these fifths. 2 and then half of that fifth. So 2 1/2 fifths, is that the same as a half? Looks like it to me. Another way you can show this is kind of using a set model. So we already did thirds, we did fifths. We know 6 are easy. What about sevenths? What if I made a set, 1 whole set of 7? I'm gonna call this 1 whole set of 7 things. 1, 2, I'm doing it in 2 groups. 3, 4, 5, 6, 7 things in the set. I would have to split that last one, right? So each of those pieces in the set, since there's 7 pieces, each piece is 1/7, right? So that's 1/7, 1/7, 1/7, 1/7, 1/7, 1/7, and then this is half of a 7th, right? So if I'm doing half with 7ths, it would be 1, 2, 3 1/2 7ths. That's half with 7ths, or 3 1/2 is half of 7. Let's try it with 9ths. Let me do my whole set again. 1 whole set. But if I'm doing 9ths, I need 9 parts. I'm going to try to split 9 in half. 1, 2, 3, 4, 5, 6, 7, 8. Now 9, I would have to split that last one in half, right? So each of these pieces in the set is 1/9 of the whole. So that's 1/9, 2/9, 3/9, 4/9, and 1/2 of a 9th. So 4 1/2 9ths is the same as 1/2. And you can continue this up with other odd denominators. But what you would end up with as you're exploring halves is you would have all of those fractions that are equivalent to half, and all of these fractions that are equivalent to half. So once your students have a really good understanding of halves, then they're ready to actually compare using this strategy of using a benchmark for a half. So now that I've done all of this exploration with halves, and I know all these ways that I can say a half with fractions because I've explored all of this equivalence, now I can actually use halves to help me compare fractions. So let's take a look what I got over here. I got a practice problem, okay? So 3/4 and 2/8. If I'm going to reason about 3/4 and 2/8, well, do I know what half is with fourths? I do. Since 2 is half of 4, 2/4 is half. It's equivalent to half. So I'm just going to write 2/4 down here just to help me get my thinking right, okay? So if I know that 2/4 is my half, then if I in fact have 3/4, I know that 3/4 is greater than a half. So I'm going to put a G on the top of this fraction to show me that that's greater than a half. Let me try that same thing with eighths, since now I can see it says 2/8, okay? Do I remember what half was with eighths? What is half of 8? Isn't 4 half of 8? Since 4 is half of 8, 4/8 is equivalent to a half. Because if 8/8 make a whole and I only need half of them, then 4/8 would be the same as a half. So I'm just going to put that half equivalent at the bottom here. Since 4/8 is the same as a half, since I'm using that half as a benchmark, but this fraction says I only have 2/8. I don't have all 4, I only have 2. So obviously 2/8 must be less than a half. So I'll put my L up here to show that. So now I can see, and eventually I won't need any manipulatives to see it. I'll be able to see these models in my brain the more I practice. So I can see that 3/4 is greater than 2/8, and I can even write that. 3/4 is greater than 2/8. And I know because I reasoned about that using what I know about 1/2. Let's try another one. So I got another set of fractions here that I'm going to try to compare using what I know about half, okay? Do I know what half is with tenths? Half of 10 is 5, so half with tenths would be 5/10. I'm going to write my equivalencies for 1/2 below just to help me keep my brain straight here. Okay, so if 5/10 is the same as a half, but I only have 3/10, then that means that 3/10 is less than a half. I'm going to put an L for less. Let me check over here on this side with 8/12. Let me think about what is half with 12ths. 6 is half of 12, so that means that 6/12 is equivalent to a half. But I don't have 6/12. I have 6, 7, 8/12 in my fraction. So 8/12 is greater than 6/12. Okay? So this means that 3/10 is less than 8/12. And I can show that. Right there. Here you go. We'll do one more. Last one, I have a hard, challenging one for you, okay? You got to really think about this one because a lot of fraction manipulatives don't have ninths in them. They have fifths, but they don't always have ninths or sevenths. But that's why we did all this exploration over here where we were thinking about what is half of 7, what is half of 9, and we can still use that same reasoning about a half, okay? So if I know that 1/2 is the same as 4 1/2 right? And for fifths, what would be the same as half is 2 1/2 fifths, because we've already explored this. Sometimes this strategy doesn't get used even though it's so powerful because we don't take the time up front to explore numeracy and equivalence with halves. Equivalence is a huge idea for fractions that you should spend a lot of time exploring, not just a couple days, because everything that you're doing with fraction computation you need equivalence with. With comparing fractions, equivalence is huge, okay? Alright, so let's take a look here. If I know that 4 1/2 is half of 9, then if I only have 3, obviously that's going to be less than half. If I know 2 1/2 is half of 5, or you can even think money, $2.50, is half of $5, but I have 4 out of $5 that's greater than half, right? So here I can see that 3/9 is less than 4/5. Okay? Now, again, if you're doing this comparison in 3rd grade, you'll always have models to go along with it. Make sure you take the time to explore those equivalencies for halves, or else your students will not use this strategy. All right, happy practicing.